8-1, multiplying and dividing rational expressions. So rational expression is a ratio of two polynomial expressions. So a ratio means it's a fraction. Polynomial means it typically involves a variable like x. So here's an example, 8 plus x over 13 plus x. The way this stands, this is already simplified, but rational expressions are not always simplified. So we're going to practice doing three things today. First simplifying, then multiplying two rational expressions, and then dividing. So the first example, we're going to simplify each rational expression, and then we're asked the question, under what conditions is the expression undefined? Well, anytime you're working with fractions that have variables in the denominator, there's certain values that are undefined because we can't divide by 0. So I'm just going to kind of put a little reminder in here, can't divide by 0. And so that's what they mean. When is it undefined? When is the denominator 0? Okay, so let's first start with simplifying and then we'll answer that question. So if I look at my expression here, the numerator is factored, 3y times y plus 6. The denominator is factored, but I think I can factor again. Can I multiply two numbers to 12 and have them also add up to -8? Well, I'm thinking of -6 times -2. So let's start by factoring the denominator. The numerator I don't need to change. And in the denominator, I've got y plus 6 times y minus 6 times y minus 2, because -6 times -2 multiplies to 12 and adds up to -8. Okay, now I want to look for common factors that I can cancel out in the numerator and denominator. These are identical factors, y plus 6 over y plus 6. When you divide two identical factors, you get 1, so we can cancel those out, and nothing else here cancels. So my answer is 3y over y minus 6 times y minus 2. Now you want your answer in factored form so that you can pick out those values that are undefined. So now you look at the denominator. What values would make the denominator 0? Well, anytime these factors are 0, we would have a denominator of 0. And we can't divide by 0. Those fractions do not exist. Or they're undefined, I should say. So what two numbers don't work here? Well, y cannot be 6 because that would make this factor 0. And y cannot be 2 because 2 minus 2 would make this factor 0. So here's your answer. We've got the fraction in simplified form, and the two values that make this expression undefined are 6 and 2. So we rule them out by saying y cannot equal 6, y cannot equal 2. Let's try this one. So this one we need to do some factoring first, and then I'll work on canceling out some common factors. So let's work on the top of the fraction. I have 4x cubed out in front, and I want to see if this trinomial will split into two binomials. So can I find two factors of -8 that add up to -7? Well, the two that work here are -8 and +1. If you multiply them, you get -8. If you add them up, you get -7. So I'm going to use my variable. I've got x minus 8 and x plus 1. Those are the two factors. In the denominator, I have a 12x out in front, and then it looks like I have a, well, I think I have a typo on this one. Hold on. I was going to say difference of two squares, but I actually made a mistake, so let me just fix that quick. It's supposed to be 64. Sorry about that. Okay, so let's fix that quick. I've got a difference of two squares, x squared minus 64. And how do we factor it? Well, you've got x times x, and -64, you're going to get -8 times +8. And they add up to 0, and that's why there's no middle term there. So the difference of two squares works like so. Now let's cancel out some common factors. Well, I see an x minus 8 on top and bottom, so I'll cancel those out. I also see that I've got 4 and 12, and there's a common factor of 4. 4 goes into 4 once, 4 goes into 12 3 times, so I can reduce that fraction into 1/3. And then I can also cancel out an x on top and bottom, and this becomes x squared if I take away a factor of x. Okay, so what do I have now? I've got 1x squared out in front times x plus 1. And in the denominator, all I have left is a 3 times x plus 8. And nothing else cancels here. I don't have any more common factors. Now, what can the denominator not be equal to? Just one value. X cannot equal -8 because that would make a denominator of 0, and we cannot have that. Okay, let me show you one more of these same directions. Simplify and then state when the denominator is undefined. Okay, so we have to think about how we can factor on top and bottom. And the one thing I'm noticing here is that I've got a common factor in the numerator. Each term has z squared. So I'm going to use the distributive property and factor out a z squared. Now, what am I left with? I've got a w in the first term minus, I have just 1 left in the second term. So z squared times w minus 1. In the denominator, I'm noticing a z cubed in common, so I'll pull that out in front. And I've got z cubed times 1 in the first spot minus z cubed times w in the second spot. Now these factors are very, very close, but they're not identical. W minus 1 is not the same as 1 minus w. So how can I fix this? I want these reversed. If I want a positive 1 and a negative w, I can actually factor out a negative sign here, factor out a negative 1. If you put negative 1 out in front, you can switch these around into a negative w and a positive 1. We still have the same thing. Negative 1 times negative w will give you that w that we had. Negative 1 times positive 1 will give you that negative 1. So all I'm doing is factoring out negative 1. I'll make a note. Factor out negative 1. This is your trick. If you need to swap the terms, like if you've got a minus sign in between them, they're not quite the same, you can make them the same by factoring out a negative 1. So now here's what I have. I have a negative 1 z squared, or negative z squared. Then in parentheses, I'm just going to switch the order of these so that they're identical factors. 1 minus w. You can convince yourself that this is the same as what we started with. It's just factoring out a negative sign. Now I can cancel out the common factor. 1 minus w is a common factor. I've got a z squared that I can factor out here. And that leaves me with 1 over z. Z squared over z cubed. You've got one more z in the denominator, so my final answer is negative 1 over z. Everything else canceled out. Okay, so that's some simplifying using factoring techniques. We used trinomials, we used difference of two squares, we also used the greatest common factor technique, or the distributive property. And then you cancel out anything in common. Let's move on to some operations. Today we're going to work just on multiplying and dividing. We'll get to adding and subtracting another time. So multiplying and dividing. When you multiply expressions, you can just go straight across the top and straight across the bottom. However, it might be helpful sometimes to do some canceling before, just so that your fraction is already simplified. Okay, so I'm looking for common factors on top and bottom, and this might get kind of messy, so I apologize if it does. So I'm looking at the 8 and 16. There's a common factor of 8. 8 goes into 8 once, 8 goes into 16 twice. Then I'm looking at 9 and 27. 9 goes into 9 once, and 9 goes into 27 3 times. So I've already reduced these numbers. Now let's look for letters to cancel out. I'll go with the a's. So I've got a to the first and a squared. If I cancel out an a, I'm left with 1a in the numerator. I can cancel out a b on top and bottom, and that leaves me with b to the third power in the denominator. Basically, your power just gets reduced by 1. Now look at the m's. I've got m squared, and I can cancel out m squared down here. That leaves me with m to the third power. I can cancel out an n on top and bottom, and that leaves me with n squared on top. So notice I'm paying attention to where the letter should go, either in the numerator or denominator, and also how many left I would have just by subtracting their exponents. Okay, so now I'm multiplying 1n squared times 1a. That leaves me with an squared. In the denominator, I've got 2 times 3, that's 6, and then b to the third, m to the third. And I always put these in alphabetical order, that's why I'm writing them this way. Nothing else cancels out because I have no matching factors, no matching variables, so there's your answer. Okay, let's try this one. The difference with this problem here is that we have to do some factoring because I've got binomials and trinomials, And you can't cancel anything out if there's plus signs between them or subtraction signs between them. So we need to put these into factored form. Now, how do you know when you need to factor? Well, typically you're going to see a squared or a cubed or some higher power other than 1. Or you might notice a common factor between the terms. Okay, so I've got two fractions here. I'm going to rewrite them each in factored form. We'll go with the top left to begin with. Y minus 1 is already a factor. I'm just going to put it in parentheses. In the denominator, I've got a common factor of 5, so we'll use the distributive property and bring that out in front. And I'm left with y plus 3. Moving on to this fraction, I've got trinomials here on top and bottom, so I'm going to look for factors of 6 that add up to 5, and that would be 3 times 2. So I've got the two factors, y plus 2 times y plus 3. And in the denominator, I need them to multiply to negative 5 and add up to 4. I could do that by using a positive 5 and a negative 1. 5 times negative 1 gives you negative 5, and 5 plus negative 1 will leave you with 4. Okay, so now everything's factored, and we're going to cancel out anything in common in the numerator and denominator. So looking all the way across here, I've got y minus 1, y plus 2, y plus 3. In the denominator, 5, y plus 3, y plus 5, y minus 1. So y minus 1 is out, y plus 3 is out, and there's nothing else in common, so I just write what I have left. On top, I've got y plus 2. In the denominator, I've got a 5 times a y plus 5. And just leave your answer in factored form. Okay? Factoring is very, very important in this lesson. I'm going to move on now and show you a few division problems. So we talked yesterday in class about how you don't really divide fractions. You're always going to change them into multiplication problems. Instead of dividing, we multiply by the reciprocal. So again, I'm going to make that note up here. Multiply by the reciprocal. That means we flip the second fraction and multiply. Okay, so I should rewrite this before I even begin. 14pq squared over 15w to the 7th z to the 3rd times, now I'm going to flip this fraction over, 35w cubed z to the 8th over 21p cubed times q. Okay, now let's cancel out any common factors. Between 14 and 21, there's a common factor of 7. 7 goes into 14 twice. 7 goes into 21 3 times. Between 15 and 35, there's a common factor of 5. 5 goes into 15 3 times, and 5 goes into 35 7 times. Now we cancel out the letters. I've got a p and a p. I'm going to be left with p squared in the denominator. Q and q leaves me with a q to the 1st on top. I've got w to the 3rd and w to the 7th. That's going to leave me with w to the 4th down here. And then z to the 3rd, z to the 8th. That's going to leave me with z to the 5th up in the numerator. So you just tell yourself I'm canceling out 3 here and 3 here. That leaves me with 5 on top. Okay, that's how you do those variables. All right, now let's see what we have left. So you want to do this neatly so that you don't kind of cross out things that don't need to be crossed out. But what I have left is 2q times 7z to the 5th. That's 14q z to the 5th over, on the bottom I have 3 times 3. That's 9w to the 4th p to the 2nd. 9p squared w to the 4th going in alphabetical order here. Now, you should always kind of check your answer. Can I reduce anything else here? I don't have any matching letters, and 14 over 9 is reduced, so I'm done. Okay, I've got 2 left to show you. So let's take a look at this one. Again, we're dividing, but I'm going to multiply and flip this over. So as I do this, I'm going to be factoring, just so I don't have to rewrite everything twice. So let me flip this second fraction. I've already changed it to multiply. So I need b plus 2 over b minus 5 as my second fraction. And now what I'm looking at here is the numerator and the denominator, they can be factored because I've got this b squared, this higher power here. So I'm going to look to factor it. So can I think of 2 factors of negative 35 that add up to 2? Well, I'm thinking 7 and 5, and I need 7 to be positive and 5 to be negative. So I've got b plus 7 and b minus 5. 7 times negative 5 is negative 35, and they add up to 2. In the denominator, I've got a difference of 2 squares. 4, the square root of 4 is 2, so I'm going to have a b minus 2 and a b plus 2. You've got one negative and one positive. The reason this works is because when you multiply them, you get -4, but when you add them up, you get 0, and that's why there's no b in the middle. Okay, now I've got everything factored. I've changed it to multiplying by the reciprocal, so now I'm going to cancel out any common factors. B plus 2's are gone, b minus 5's are gone, and now my final answer is b plus 7 over b minus 2. Remember, you cannot cancel out those b's because they're part of a binomial here. Okay, last one. Sorry if this video is getting long. I want to show you what to do if you see a problem like this. This is called a complex fraction because we've got a fraction divided by a fraction, or a fraction over a fraction. What this means, though, is divided by. Remember, this fraction bar means division. So I really have x plus 3 squared over x squared minus 16 divided by x plus 3 over x plus 4. So we're going to think about it as a division problem when we're simplifying this fraction. Now we want to multiply by the reciprocal, and as I rewrite this, I'm going to put them into factors. So I'm going to flip this fraction over into x plus 4 over x plus 3. And in the numerator up here, I've got x plus 3 squared. That means there's 2 of them. I'll rewrite it twice. And then in the denominator, I have a difference of 2 squares. X squared minus 16. That's x minus 4 times x plus 4. Okay, now these typically work out nicely because that's just the way the textbook writes their problems. So let's cancel out some common factors. X plus 3, x plus 3. X plus 4, x plus 4. Here's what we have left. X plus 3 over x minus 4. Okay, now it's time for you to try some of these. I've got a multiplication and a division problem. Go ahead and work them out. Really think about how you're going to factor these if they've got a higher power on their variable, okay?